All right. So I want to start talking about chapter 1 today. This is for CSC200. Okay. So let's start with. Again, you may try to visit. You can pull up your YouTube, my channel. You see on your screen too. If it's very hard to see from here, because it's now live. Okay. And I think the link, maybe I provide a link to, yeah, this is a URL. Let me post that. Not sure you can try. This is first time that I try here. Let me know if it works or not. I'm going to post a link now. And the announcements. And please let me know if it works. Yeah, it works, right? Is that right?
I think mine's live.
Yeah, it's physics. So
It's supposed to be
yeah, it's over
behind like 10 seconds.
Okay, so it's live, right?
Yeah.
Okay, good. Like I said, if you happen to be somewhere you cannot show up to the class, you can watch live too. Okay, so I try to do that for every class meeting. Then you're not missing anything, and so it's supposed to record too, right?
Yeah.
Right. All right. Great. So last class we were talking about introduction to the computer, right? And we just review our binary code, right? To hexadecimal, to ASCII code, right? Which is the characters, right? And to octet. Now, those are the basic computer language that's converted to human language. So, because an overview is, we want to make sure that you understand computer hardware and software, right? I show you computer hardware itself, like physical motherboard, right? And software is pretty much just something that we created. The most important thing is like operating system, right? Operating system, who actually going to convert like human language to computer language, right? So binary, right? 0110 that we just learned. Like now we know how to convert manually by yourself, right? So technically we can make a program to do that for you. That makes sense? Yeah. And that's operating system. Like one of the duty of operating system is going to do that. It's going to be more than that, but just that's one piece that we've seen. Now, there's an image that I'd like you to take a look at. Okay. So let me get the image. So this is going to be about computer architecture. Okay, so it's all about, you see this in CSC205 when you take the class for CSC205 again. So technically I want to visit that class first in order to get the slides for that, because I like an image. Okay, an image that's showing, talking about how users interact with the physical machine. Okay. And it makes more sense when you look at this image. All right, so I'm going to download this and share this on our textbook slides. I'll add these slides to that. Okay. So I'm going to add that to under textbook and slides here. Textbook slides. Then you should have this. This is for CSC205 textbook, but I just want to show you the image from that. Let me browse that and attach the document, then you can download this. That's the one. Now we will look at chapter 1. Okay, chapter 1 from that slide. All right, so this chapter 1 is just talk about physical hardware. Okay, so an overview of computer hardware, like the machine here, right? So we were talking about computer hardware. Like when you go to purchase a machine, you technically have a question: what's cache, what's PCI, what's gigahertz, what's gigabyte, right? So that's gigahertz is the speed of the CPU. Gigabyte is a, we talked about bit and byte already.
Yep.
So that's a memory, right? How big? Like if I want to store a letter, you need 1 byte, right? If you want to store like mega is million, giga is trillion letters, you probably want 1 gigabyte at a minimum, right? Yeah, something like that. So this is, we're talking about the units. This is in matrix system, like kilo, mega, giga, right? 1 billion, mega is billion, tera is trillion, right? So you see, it start to have, after tera, it's going to be peta and exa, right? We're going to see that soon. So I see it's every maybe 5 years, you see it's going to change mega to giga, and then giga to tera, tera to, now we are at tera, right? So in maybe in a few more years, we'll see peta, right?
So the ones that are from peta to yolta are just, how you say, hypothetical right now until they exist?
Well, I mean, they're paid in real things. But
Right. This is just the matrix, like units, that in physics they use that. Like when we want to define something big, instead of,
But like
But there's
the,
still nothing like a Yoda byte.
right,
Yeah,
that's
that's what-
nothing.
that's what I'm thinking. Like those are things that have yet to exist still.
Not existing yet, but it's going to be. It's dependent on the technology that we
It's kind
get
of
to.
weird to think about. Is like we kind of predict the byte size, like that can get so big, and then we're slowly getting there.
Yeah, we're gonna get there anyway, right? Because we
There's a lot of-
depends on the technology. Like you see the history here, we were using,
that gets bigger. Computers
like the first generation is, I showed you last time, the computer is ENIAC, right? ENIAC is the first generation. We call ENIAC. But we have like generation 0, which is what? Pretty much your calculating clock, Pascal line, difference engine, punch card. So, I mean, if you want to look at the picture like Pascal line, you see this is pretty much in the old time. That's the computer at generation 0.
Wow.
Mhm.
When was the first like computer that we know of made, like in terms of like the big rooms and everything that were?
Generation 1.
When was that? 19 something?
When we start to invent the vacuum tube.
Ah.
So this is like your light bulb that I'm talking about, 0 and 1. It has a gas, no gas is 0, gas is 1. So yeah, it's in 1945 that we have the ENIAC.
Oh, okay.
That's a machine that we seen it last time. And then you see, it's depend on, like I told you last time, the algorithm is already exists. It's just math, right? Like we have that since the mathematicians in the old time, maybe 500 years ago, already know this, correct? But we don't have the technology to creating it yet. Like just like you just said, we try to get to Yoda byte. We don't have the technology just getting you to Yoda byte yet. Until once we get that technology, pretty much the material, like now we get a material called what, transistors. Then the machines start to be smaller. IBM start to produce their machine. So the size about your refrigerator at home, instead of the whole classroom. And now it's commercialized now in business use, scientific use. So you may see an image. IBM right? 7094. This is for scientific. And when you see, it's gonna be very interesting, right? Like I said, that's the machine, right? That they use right there. And you see those are the tapes, like your storage. And it's like the old hotel like register desk, right? That's transistors. Then we invent integrated circuits, the small chips, right? So you guys know IC like that. Oh, not that one. Like integrated circuit. So this is pretty much in one. We can have like about 12 transistors inside. So it makes it smaller, right? Then that is you see, this is all about the technology that we invent, and we think this transistor pretty much you store the electrics, and that's one. It's just like light bulb, right? And when you store the electrics, that's 0. Yeah, that's about transistors. And then fourth generation is starting from 1980 at VLSI, the very large scale integrated. Now when you open your phone, you see it's only one chip. That's a VLSI technology. So it's like that small chips like that. Yeah. Like inside your iPhone. Let's see. Like that small chip, see that? That's VLSI technology. Like this whole chip pretty much just represent your whole computer. Like the CPU that you see big, it can be very small like that now with that technology. No. This is the Wi-Fi chips. This is the data, right? Connection chips, and this is pretty much your whole CPU and everything. The memory. This is the SIM, right? This is the things to control the touch screen. See, it's very interesting, right? And if you really look at this, this is really what $800 you pay for. Right? Like this type of the integrated circuits that I just show you, right? This IC, if you want to check the price, it's like okay, let's say they have AND or NOT gates. Yeah, 7400. We'll show you if they have the image. This is a spec sheet. These are gates. And there's a brand. This is a small integrated circuit I show you, right? That they have 4 NAND gates inside. This is like about maybe 20 cents a piece. Okay, and the chip itself, like VLSI, can compose of this 10,000 of this in one. That small chip that I show you on the iPhone, right? So because of technology, like old time, one gate right there combine about 12 vacuum tubes. That's why the machine's so big, right? But now we can put 10,000 of them in one small chip. So So that's why it's so small, but the tail is still the same. Now this is an image I want you to see. Like we were talking about this level 0, right? Digital logic and or not, right? Like you learn in 205 how to make your own CPU. Okay, you can build your own CPU. All right, and this is you, right? User who play with the computer. There are layers that you actually try to communicate through the and or not gates, or that physical level that I just showed an image to you, right? Pretty much just 0110. That's what it is. So, and how could this computer understand and do things like the user tell? Then we are at level 5 here, which is this class we were talking about, high level language, which is your Java. Okay, now Java is going to be a high level language because it's close to machine. No, it's close to human. So it's an English, right? So let's say I'm going to show you an example of Java code. I'm looking for Java file. Here you go. So this is the first Java program. Hello. We normally call Helloworld. You guys know, right? Helloworld. That's, if you never programmed before, you should program Helloworld. And when first time Android apps created, the student just program Helloworld and sell it on apps store and make a lot of money. People download it and pay for that. So this is hello world means what? You want the application to say hello world to the screen. That's it.
Yep.
So in Java, this is a syntax for that, and this is high level language that we just look at. It's close to human language. It's easier to read. It's not low level language. Low level language could be assembly language that close to machine language. Like machine language, we know that we cannot read it because 011001, right? We just seen it from the previous class. So now, if you write a program hello world at level 5, the user is going to execute this program, right, at level 6. So how to execute this program? So you can make an icon for user to launch it, double click and, right? That's one way. And you can run it from the command prompt or console. This is operating system. Let's use a command. Like you type the command Java, right? Like now, I type the command change directory, just like when you navigate, right, to the location. Like if I want to go to desktop, I click. This is a graphic user interface command, right? That, okay, I get to hello.java. So this is a location we call file path, right? Which if I do the same with the command DOS, this is DOS, like a command interface. There's no click, no GUI. I just need to type the file path and then CD is just move me to the same location right there. So I type DAR, it's just give me the list of the file, like 2 files. It's just the same thing, right? And the details, date created, the same type, right? Size. I want to compile it. Let's talk about at the user level again. We just want to run it, correct?
Yep.
So you're going to do Java and hello. Just call the program name. Or if the user interface, you just double click on it, right? Then When we hit, it say hello class, right? Now I make changes to hello world. Once I make changes, so at this level, user still run the old program that I have. So that's why I say hello class, right? Now, if I want to upgrade, that's why when you download the app, sometimes they ask you to update, right? Because otherwise you still have the old version running. So as a developer, I make it to say hello world. So I change with my Java code. I have to make the computer know that, communicate to hardware, right? So I have to recompiling it. So now we talk about compiling. So what's that, right? So in chapter 1, everybody read that. So what did you find out was compiling? Anyone still remember?
So which question?
Compile.
The Java C?
Yeah, that's
Yes,
command.
the Java C. Compile. So Java C stands for Java compiler. So I have the source code .java. This is my hello world, right? Hello.java. That's Java source. So I want to make it first. I need to compile to bytecode. All right. So even go to Java. Let's talk about general idea of compiler first. So a compiler is scan the entire program, pretty much your code, right? And translate it as a whole into machine code. Just like what you try to convert your ASCII into 0110 binary, right? So it looks like that's a you were a compiler last time. We do introduction 1.1, right?
Right.
Now we're not gonna do manually. We're gonna make compiler do it for us. Make sense? It takes large amount of time to analyze the source code, but the overall execution time is comparatively faster. After compile it, what it's going to do is going to generate intermediate object code, which further requires linking, hence requires more memory. It generates the error message only after scanning the whole program. So it's not only translating, it's also try to check your Java syntax or grammar, right? Because if you write something wrong, it's going to, let's say for example, this is Java syntax. It's say lowercase, uppercase mean different. It's case sensitive. If I happen to put all uppercase. Alright, so we're going to save this file, right? I just hit Ctrl S, the same as save right there. And then you're going to recompile this with the Java C. Is you pretty much need to know the command here. And how do we get Java C? You pretty just need to download JDK. So you will have to download JDK to get the compiler. Okay, you can get the JDK. Now it's on August 8th. They just released JDK 9 like early this month. So I just download that one. It's still early, but I want to test that. You can download that to use too. Okay, that's the latest version. So you just go and pick the OS that you use, Windows, Mac, or so on, right? And the machine 32-bit or 64 bits, and download that and install on your machine. Once installed, it should be located inside C. You just need to verify that it's going to go into C program files, right? And then Java, and then JDK. Like now I have two versions. I just download JDK 9. This one is the older version, JDK 8. Okay. So once you install, you have it there. So inside the bin folder is where the compiler is named javac, right there. See that? So now you're going to set the path. Like, what's that mean? Remember, we want to compile the code. I just installed Java, like JDK, which has the compiler, and we know what's compiler now, right? So the compiler is going to translate this for me and check the syntax, right, to the machine code, remember, and check the syntax if it's correct. So how am I going to do that? Like I said, download it, and you're going to set path. If you don't set path, the program still in that path. It's not going to be recognized through this operating system or DOS. So what you need to do, you need to copy this path. Okay. And in Windows, to set path, you just go to you can right click on the computer, this PC, and go to properties and go to advanced system settings and go to environment variables, and you're going to see path. So looking for path right there, and then you just need to add that onto it. Like, you can paste that. Oh wow, that's one way. Alright, another way, I already set it through my Java home bin, and my Java home, I create the variable named Java home, variable named Java home, which is the same point to JDK. See that? So that's why it's the same thing. You want to do it here and this at the bottom too. Like where do Java home, I set the path, the same path, right? Like I said, the two ways you could just create variables like that and do Java home. Alright. And then you go to path, right? And then you just hit edit. And like here, I just set /bin, which is Java home just pretty much technically hold the first section, right? First half of my path. So the same thing, just puts percentage. So that's how we set the path. Once we set the path, then you hit OK, and then we should be able to compile your file. Like now, I need to call javac, right? That stands for compiler, Java compiler, and the name, right? Hello.java. So it's going to build. Now it's checking. Remember, I said that's an error that I put on, right? See that? They said something wrong with the word public here, because not only translating but also checking the syntax, right? So one error is expect a class. Like now I have a class, but that's not the right syntax. That's what I say. Then I'm going to fix that. So Java is case sensitive, meaning uppercase, lowercase meaning different, and we can see the ASCII code for those are different. That's why, right? Alright, so now there's no problem now. So what it does is, just look at this. I'm going to delete hello.class. This is your object file, pretty much, that it's just talking about, right? So javac hello.java is going to create that file. You see that? Once there's no errors, so it's going to create that file, right? So compiler, right, is going to, let me go back to where we see it here, right? translate it as a whole into machine code. So it's try to translate into binary code. So source code, we have compiler processes, okay, to object and then process again to machine. Now if you look at Java, so Java we have right here, we have .java. After I compile, it's create .class. We call Java bytecode. So again, this is .class. See that? So we have Java bytecode created after I run Java C. So I just show you this process, right? So now, next step is, what's Java bytecode? Good thing about Java is it can run on Mac, OS X, can run on Windows, can run on Unix, can run on different systems. Like the old time compiler like C, C++, you see that Java is not even counted as compiler language. Because C and C++, after you create, it's going to create .h instead of .class, and .h stands for hexadecimal. It's very close to a machine, right? We've seen it last time, hexadecimal number. And then it's get processed again into machine, that hexa. So that's why we have all the layer here. When you compile, technically you compile into assembly code. Assembly code is lower level language, just like close to hexadecimal language. Like .h in C is pretty much like assembly code. And then assembly code is going to get processed again into, so by operating system who translate it again from hexadecimal into 0110, which is close to instruction set architecture of the machine. Now, below this level, you learn in 205 how it works. At this point, you just need to know that it's going to get translated into 101001 from operating system, from assembly code or .h. Okay, and then when you get to that, it's going to get into like very low level like driver programming. Like when you buy hardware, you have to install a program for it, right? So it's just get into very low level. Like the hardware itself has the program at that level to communicate back to this level, and then it's going to change it into 1001 and pretty much do the command that whatever you tell it to do. Like only and or not actually create everything, like add, subtract, multiply, divide, and from there pretty much if you know how to do that, then you can do if else, you can do logic, and then you can do everything like math, accounting, engineering, because math is the basic of all the subjects. Make sense? And it can store the memory. This thing can create memories. So that's why you can store data, you can process data from there. It's so amazing that this is all come from and or not. And you learn in 205 how it happens. It all just come from those three logics. And those three logic gates I show you is in the physical level of your hardware. Okay? Now that's how it happens. Now come back to, we have a compiler, right? That's the concept of compiler. You see C, C++. The problem with this program is Once you write it in Windows, you can only run on Windows. You cannot run on Mac or Unix. You have to write on Unix or Macs separately. Just like now you have Android. Can you run Android app on Apple? No, you cannot run Apple on Android, right? Which is kind of annoying, right? And when you have to develop, you have to develop both. Like that in old time, they do that, right? Same now. Now we are just like same thing as the past. In the future, you see that it's going to be integrated in one, right? So that's why we have Java. Java just answered that question. So how would that happen? So Java has the runtime environment. Okay, so what's that? If you look back to the folder that I download my Java, I also normally when you download JDK, it's come with JRE. JDK stands for Java Development Kit. JRE stands for Java Runtime Environment, right? So just like that, runtime environment. So this blue part is JRE. So this is the JDK. So now when you buy your computer machine first time, you cannot run Java code. What do you do? Download JRE. First time when you buy a machine, you try to run a program you cannot run because a program that is written in Java need to have JRE. If you're not developing, you don't need JDK, right? So you only need to run the bytecode. So when you debug, it's create the bytecode for you .class. But when you run, okay, let me show you. When I run, I just type what Java hello. I actually technically call hello.class right here, right? You need to type .class because Java is going to run .class. Now it say hello world. Right after I recompile it, so I have the new version, so I can run hello world. So it happens like that. Like it's going to get into JRE, and JRE is going to call. Pretty much JRE has what? Java. JRE has the command called Java. If you really look at inside your JRE, it's go to the bin again, and it has Java right there. That's what you need. That's right. And the rest of the file is going to help Java. Pretty much just in this image, you see they have the class loader, bytecode verifier. Those are Java interpreter and Java in-time compiler. And this is called JVM, Java Virtual Machine, that has runtime system that talk back to operating system, and OS change it to hardware level that we see. Then that's why it's C. I want to say hello world. So they go to those level 0 to level 6, right, in the image that we see here. Right? That's the whole thing that we just did. So we are only worried about level 5 for this class, right? Writing an application. And when you take computer science courses more, then you go into this level, deeper and deeper into details. That makes sense? And we really need you to decide better technology for the future. Each level takes time and take a lot of engineering to make it happen. Okay, but we only at this level. All right, so that's all computer science about. So a lot of people said, what's the difference between computer science and IT? So IT only focus on user level and level 5. You write application for user and support the user help desk. and develop applications. But computer science is we focus on all the architecture here. We have to write operating system, which IT will not write OS. Right? We have to write instruction set architecture, which is when you get to that level, you have to talk about computer engineer and computer and electrical engineer to design the circuits and hardware to support. But you have to work on the communications to the hardware. So that's the difference. That makes sense between IT and computer science. All right. Now, come back to, we understand that Java, is Java a compiler language or interpreter language? So we understand we do Java C to compile, it build a bytecode, and we have to run through Java hello, like JRE, right? And JRE is depending on Java interpreter. Now, they were talking about interpreter language, right? Translate program one statement at a time. It takes less amount of time to analyze the source code, but the overall execution time is slower. No intermediate object code is generated, hence are memory efficient. Continues translating the program until the first error is met, in which case it stops. Hence, debugging is easy. Programming language like Python, Ruby use interpreters. So, source code, intermediate code, and interpreter. So, let's look at Python. So, Python, I have Python installed on my machine. So, this is Python prompt, where this is an interpreter language. We see the compile. We have to compile first. And interpreting, we have to, I want to say hello. I just say print. In parentheses, like function print in math. Hello. Say hello. Say hello world. That's it. You don't see, this is your source code that is get interpreted and put it output right away. You don't need to compile it. Before I show you in Java, you cannot do that. You have to compile, check the syntax. If there's an error, fix it, compile again, and then you have to call Java hello. So this is like interpreted at this level. But compile first, right? But interpreter language, you just interpret the code right away. You don't need to compile. So that interpreter. Now, when you look at this, this is a Java interpreter, like when we call Java hello, right? To run our hello world right there, right? But this is a compiler when we call Java C hello.java. So when you write program in this class, you have to do compile and do interpret, right? So both pretty much is Java, right? It depends on how you look at. If you look at, you already have your .class, then Java can be just interpreter. That's called, right? Alright, now we understand what is interpreter and compiler and what is different. So let's look at your class exercise. So for this class exercise, it's going to be chapter 1.1. You're going to have to, I show you how to write a program hello world, right? You can review from the videos again. Now you need to write a Java program in Notepad. I just show you. So this is the Notepad Java program. So Java program, let's learn the Java syntax. It's always surrounding with curly braces, open and close. So the first one always come with a class. Public class is a must. So if you look at the skeleton of Java program, it's pretty much just have public class, and then this is just the name of your class, which is, it could be any name, right? And then when you save the file, it's going to be the same name as your class name. Okay. Now, if you're using Notepad, like for example, if I want to write Java code, so I'm going to say public class. That's the syntax as a must. And let's say loved Java as the program name. Open curly braces and close it right away. Right, and like the main code itself is public static void main. It's always going to be like that, string args. So this is open and close again, and this is called a main function, but Java we call method. So a main method, okay, it's just like math function thing that you call the function name main with the arguments or parameters. Okay, so if you look at in math, right? In math, how do you use function in math? So we call f of x f of x, that's for function, right? So f is represent your main right there, and x is just like the whole string brackets in the args. That makes sense? Now every Java class is pretty much just the unit for your file. Java file has one class, one file has one class right there, right? Now when you save, you're going to save this as so when we do save as, we're going to save it as the same name as your class name, love Java. If you have different name, you're not going to be able to run Java code. And again, by default, if you use Notepad, it's going to add txt at the end. But we don't want to do that. We just want to switch to all files because this is a Java file. And then going to type, it's case sensitive, right? Class always capitalize it. Always capitalize the first name of your class name, first letter of your class name, and no white spaces. We call camel case. This is a camel case. Like use uppercase between the word to distinguish the word. The camel case. Don't include white spaces, and no special characters. Okay. Like no exclamation mark, no percentage sign. Don't start with that, and don't use number to start with. And then .java, and then enter. Now you see that we just saved love Java. How do we compile? We just show you last time, right? So let me exit from Python. Exit. So when I do the AR, I should see if I have it in this right location. So I have to change my path because that's not the one. I put in CSC200. I have to go back one folder, cd CSC202, and then dir. So there you go, love Java, right? So we have to compile this. How do we do that? Java C love Java.java, right? No errors. It's going to build If you dir again, you see dot class is created, right? After compile, get dot class. Now we run. Okay, nothing show up. Why? Because this is just the main Java program, like skeleton. I didn't implement the code yet. So if I wanted to print something, I have to say system.out.print, and in the quotation double quote where the context is gonna go. Like in this case, I say I want you to print I love Java. Java is fun, right? Let's save that. I just do Ctrl S to save. Recompiling it. Every time you have to create a new bytecode to get the update version, right? And then you're going to run it with Java. So just type Java and call love Java. Then you say I love Java. Java is fun. So that's technically your assignment, right, for this one. And again, this is an instruction to tell you that how you want to do it. Remember, you have to go and locate and install JDK. And now you want to get the latest JDK. Like now, I was talking about 1.8. Like I said, August, like earlier this month, they just update with 1.9. We technically can just say you verify that. I show you this step already on the on the video. You can go back and review, right, on our live on YouTube here. Just make sure you subscribe to my channel, then you get it, right? So we get the JDK 1.9 at this point. Make sense? Let me show you one more time how to verify that. You go to your file explorers. Okay, I'm going to minimize this. C, right? C program files. So go to C, go to program files. Again, program file, this is a 64 bits. Okay, and where? Java. And that's it. You see JDK. Actually, it's 9, right? -9, not 1.9. So if you already have it, you see it. It's just trying to tell you to verify if you have one. In Mac, you just need to do that one. Now, if you don't have one, if you have one, you can skip step 1 and 2. I mean, you don't need to get the 9 edition if you have JDK 1.8 or whatever earlier. That's fine too. But I would recommend at least 1.8 because we can use JavaFX. Then earlier than that, it's not going to support. Okay, always get the latest edition. Like you update your apps, same thing. So now after that, like I provided links to download, right? So I show you how to download that if you remember. Let me go back and show you the link again. You technically just Google download JDK and then that's the link. So I'm going to upload the link, update the link. So you pretty much just need to get JDK from this link. And after you get JDK, remember what do we need to do? We need to set path, right? Correct? So this is just verifying that you have, after you install, right, get JDK, right, download JDK and install. Okay, install pretty much just launch it and follow step next, and then you get a JDK by verify again. Okay, So pretty much just repeat this step technically, right? Like that one before you download, you verify, but now since you don't have one, you download and you verify again. So after you verify, then if you happen to use Mac, you might want to follow my video here, how you link it, okay? Alright, so you start to write a program. I show you how to write program in using Notepad, right, for PC. And then if you use Mac, you can use text edit and just write this code to say hello world. Save the file, make sure it's gonna be hello world.java. Like I said, not .txt, by switching to all files, right? This is for PC user. Okay. Now, after you finish that, you're going to compile this. You're going to go to the terminal on Mac or CMD. Like, I just type CMD to open that, right? The DOS screen you want to compile, right? So, and this is for the PC user. This is for PC user, you launch that. Now set the path to the location where you have, now you have to set the path where you have your JDK. So I show you, you can set through the windows. Another way, you can just type the command set path. Okay, that's another way. This has to be, since we have 9 JDK 9. Okay, like you can just say set path equals like that. That's another way. And you, if you don't do this, you could just, like I'm talking about, you could do copy this command, but you have to verify that the path is there, otherwise it's not going to work. That's another way. But let me close with quotation. Yeah. And now, if you set by Windows, I showed you earlier, under the system environment, you don't need to set path manually anymore. But if you don't do by Windows, if you type command, you have to type all the time when you launch CMD. Okay. So that's why I would recommend you to do the Windows one instead. Then you don't have to do this all the time. Okay. Now, or set path under environment variables. This is for PC user. Okay. For Mac, you don't have to do this. It's going to do it for you. Okay. Now, this one you have to watch my video, okay? Like I already record that, so you can search by like set path. Like I have more than one that talking about this. So set path. Here, this one will show you. You can watch this video or even my video that I'll be recording here. Okay. Alright, so setpath is done. Right? Install is done, setpath is done. Code is already coded, save as Java. Lastly, just do change directly to location where you have your file save, right? So now we have to learn the command now, right? Command change directory is cd. By typing cd, is show you here, and the location where you have your file saved. Like now, I save my file on my desktop. Technically, if this is the hello.java, I just copy this path, Control C, and right click and paste that, or you can manually type the path, and then it's going to change the directory to that location. Now once you get that, you go to step 5.5, you do javac and followed by the program name, right? Like I just named hello.java. So it's compile hello. If there's an error, you just need to go back and fix your errors. Okay, so the easier way to fix is just compare each letter by letter, okay, to your code, to this, then you find out what's wrong. Case sensitive, uppercase, lowercase is going to be a problem. And semicolon, don't forget that, add the statement inside the program. Like Java, it's going to end each statement with semicolon. This is the real Java implementation code inside the skeleton, right? Inside the class is open class, closing class, method is open method, this is main method, and close method, main method. Alright, so once you complete Java, you pretty much just get the program running. And just change the word hello world to I love Java. Java is fun. And that's your assignment.
Okay.
And we save it, recompile it, and rerun it. And submit that snapshot. And submit your code. When you submit submission requirements, so how to submit assignments, that's where you want to go. So let me update this and we go to that one. So how to submit assignments is going to show you. Alrighty, so this is your notepad, right? We just talked about. And another one is Eclipse. Let's use, let me ask you to use Intellij, okay, at this point. I'm going to ask you to use Intellij. Last time did I tell you to download Intellij? Not yet, right? We're going to use Intellij idea. Alright. So we change that to Intellij idea, okay? So I want you to go to course documents. Oh, actually web links, sorry. Web links. And under web links, you see Intellij idea download. You have to complete 2 steps. First step is the students. So this is just apply to get an Intellij license, because if you're not a student, it's normally cost you $400 a year to use this software. So you use the NOVA email and apply that. It's free for 1 year as a student license. Okay, you go to that and fill out this information, apply for that. You could do it now, then it's going to send to your email right away. Okay, once you sign up, then you go to the second link to download. We want the ultimate version, that's why it's $400. So the free version is the community, but it's not going to work for our class. We're going to go more than just the standard. It may, but I want to show you more. Okay, so we download this one. Okay. Alright, so once you download, you install it on your machine. You will see this icon on your desktop. That's Intellij idea. So what is it? This is called IDE. IDE stands for Integrated Development Environments. So just like when you want to write a research paper for your English instructor, would you use Notepad? No. What would you use?
Word.
Microsoft Word. Why?
It's designed to do better.
Why is it better? It's why is it better?
It has formatting and all sorts
Why?
of things.
Spell check, formatting, indent, thread. Same thing. Is it user friendly to write your Java code?
No.
In the beginning, it's good for you to use it to learn. Then you make. That's why I asked you to do both. I would recommend you to do Notepad first. Okay, if you want to learn, because some students actually they do the other way around. They just do Intellij first or Eclipse first, and then copy the code and paste, which is not gonna help you. You should try writing this first, and then once you're done, then you copy this and paste on Intellij to see what is wrong with your code, because it's going to tell you right away what's wrong. Just like Word, when you type in Notepad, you don't know if you have like spelling errors. Once you copy and paste, then Word tell you you have typo, just like that. So for the learning purpose, that's why I asked you to do both. You type in Notepad, right? And then you try to compile, you get other errors. Now you don't know how to fix, you copy and paste in Intellij, and now it's going to make format. Like now, let me show you how to use Intellij. It's going to make your format and identify all the errors for you, and then you can use that to assist you to debugging all your errors for the syntax errors. Okay, then it's going to help, and then you can just use Intellij to run the code too. That's why I want you to submit both. Okay, so you're starting from this assignment, you use both, and I show you how to get all the programs, right? So you have to download a lot of things when you go home today to set up your machine for development environments. So I'm going to create a new project. Okay, so how to use Intellij. Once you start, you go to File, New Project, and this is a Java project, first one. And of course, this is where you want to link to your JDK 9, right? For the first time, it's going to be empty for you. You have to go to New, JDK, and go to the same path where you have your C, right? Same thing, C, program files, right? Java. And then pick your JDK 9. And that's it, that's Java Home. That's what they're looking for, right? That is your SDK, Standard Development Kit, which is JDK's Java Development Kits. Okay. Next, if you want to test with Java Helloworld template, you can use that. If you want to write from scratch, you don't need to use that. So now it's going to write Helloworld code for you, which that's why I would not ask you to do that first. You should use Notepad first. You should learn how to write this whole thing on your own. Okay, so this template write the code for you. The same thing that we have. Make sense? And this is just a navigator for you where code is. And then we hit play button. This is going to do Java, C, and Java for you. And then at the bottom, it's going to show the result, which is just like your console. And it's going to say hello world. See, with Intellij, I don't have to type any code just to view hello world. I just click, and click. which is not good when you're still learning. You should use Notepad. I said, okay, if I use Notepad, so what I do is I just create a new project, right, again, and go to next. Don't use the template, just create from scratch. Hello, finish. Yes, okay. And now I just go to my Notepad after I done, right? I'm going to open new file, okay? So click on the project. This is not the Java file. This is just the Intellij file. So we go to new. I want to do new Java, right? New class. Right click on source, go to new Java class. And this class name what? Love Java, right? Hit OK. Yes. And just paste your code from Notepad. And then save this and hit the button play and run. Okay, and it will just do the same result for you. Alright, so that's pretty much it for today's class.